I have a mouse problem. A tank mouse problem. Yeah, it seems a couple of these are no longer working correctly. They've basically lost their vertical movement, although I can still move them horizontally. And it seems like this is a fairly common problem with the Amiga tank mice, or at least some models of them. So today we're going to have a look at what causes this issue and to also delve into how these mice actually work. And then we'll look at how to fix this problem and, as a bonus, calibrate these things to have them working better than ever. So here we have 4 tank mice, and from the top side they look basically the same if you ignore the very yellowed one, but on the underside we do see a few differences. So these two over here have a slide down tab to release the mouse ball and 4 sort of glider pads, and these ones have a little twist tab and sort of a semicircle and horizontal glider pad. And it's these two that are having issues while the other two are working perfectly fine. And yes, I have gone through and cleaned the mouse ball and the little rollers inside. None of that has made any difference. So even though I only have a small sample size here, it does seem like these ones are the ones that are more likely to develop a fault. And I believe these are an older model, whereas these are slightly newer. And while the internals look slightly different, functionally the circuit inside is the same between all of these. But let's start off with the ones that are not working and then see if the ones that are working also could use a little tweaking. I think we'll go with this one because it's not yellowed, so it's not as painful to look at. So there are only 2 screws on the bottom of these, and then the top shell should just lift off. And I have a message. Here we go. Oh, and I suppose while we're here, let's have a look inside one of the, what appears to be more modern mice. And there we go. So while they do look different, that's mainly down to the actual mouse buttons. These ones use little tactile switches, whereas the older ones seem to use a little dome switch. But aside from that, the actual circuitry in these is practically identical. So I'll put the more modern one aside, but we will come back to that later. Let's focus on the non-working one. So let's just check this on the Amiga. So we'll just power it on. And I think I've got the Amiga test kit disk in here, so that should load up pretty quickly. Yep, there we go. You can also use Workbench or anything else that uses a mouse for this test, but yeah, as you can see, we had a tiny bit of horizontal movement and no vertical movement. So there is some life in this. We can even go into the port test. And yeah, we do have left and right buttons working, somewhat working. The dome switches in these are pretty junky, so we might also replace them. But our buttons are working, so at least there's some life in this mouse. But yeah, we don't have any movement. And even if we pop the mouse ball out, which of course I've already cleaned, and I also clean up around these sensors, we can turn the actual mouse wheels themselves. So there's one down here for the horizontal movement and one over here for the vertical movement. And yeah, even moving these manually, it's pretty much stuck in one spot. So I don't think this is going to be a cable issue, but you can obviously test the cables just for continuity, just going between the connector itself and the connections on the PCB. PCB? PCB way! Yep, whenever I think PCB, I think PCB way. Not only can they handle all of your PCB prototyping and assembly needs, they also handle CNC machining, 3D printing, and a whole lot more. And while you're there, be sure to check out their shared projects section, where you'll find all kinds of interesting ideas and creations from other members of the community. So head on over to PCB Way today, and we thank them for sponsoring this video. So I've already tested the cable on this mouse, and yeah, it's perfectly fine. And as we've got some signs of life, I don't think it's going to be an issue with the Amiga. If it didn't work at all, then yeah, we could suspect the Amiga, but yeah, we can pretty much rule that out. It's got to be something internal to the mouse. And in order to troubleshoot one of these things, we first need to understand how it works. So let's get these remaining screws out and take a closer look. So as I mentioned, we have these wheels that determine the horizontal and vertical movement, and the way these work is by shining an infrared light from these little transmitters here, there's clear bits of plastic, through a wheel with a bunch of slots cut into it to two receivers that are hidden underneath this plastic part. So there's two for the horizontal and two for the vertical, and the reason there's one on either side is so the Amiga can determine if we're moving the mouse up or down or left or right. And we can actually test to see if these transmitters are working simply by plugging this back into the Amiga. And I'm not sure if this camera is going to pick it up, but we may be able to see tiny little what looks like purple lights coming from those transmitters. You can also use a mobile phone camera for this, and you might have better luck with that. And indeed, on my phone camera, we can clearly see all four transmitters are working. So the next logical step is to check the receivers. And while you can use a multimeter to do this, it's going to be a lot easier to do with an oscilloscope, and it's going to be a lot easier for me to show you on the scope. So I'll just hook up my ground lead to one of these points on the outside of the board. So this area, or this big long trace that goes around the outside, is all ground. And if we take a look at one of these receivers, which are going to be either this one here or this one here, we've got 5 volts there, so that's power going to the receiver. So this must be the output from it. And if we turn our little wheel, you can see that there is a tiny bit of activity there, but it's a pretty low voltage. Let's zoom in. There we go. So as the wheel's turning, we can see that the receiver is actually responding. So it does appear to be working. Let's check the other one. And yes, again, we can see there is some activity there as we move the wheel. So it does appear that both of those receivers are working. Let's just check the vertical ones. That must be the 5 volts. Yep, there's activity there, and must be this one. We have activity there. So we definitely know all the transmitters and receivers are working, and as I said, you can test this with a multimeter, but it's not going to be as obvious as an oscilloscope. So multimeter set to DC. If we just go back to one of these points here, you can see we've got almost 0 volts. And as I move this around, you can see that voltage does jump around a little bit, but obviously it's going to be really hard to figure out what the actual extremes are, but at least you can tell that something's happening. So you might be thinking there's an issue with those voltage levels because they're obviously well below our standard TTL levels that we'd expect to see, but that's where the next part of the mouse comes in, and that is an LM339 quad comparator. Basically what this is doing is taking little changes in voltage and amplifying that to our maximum levels. So let's have a look at the inputs on this thing and check the outputs as well. So we can see if we trace the output from one of these receivers, so that's one there, it goes up here to a component there and eventually ends up at pin 4 of our LM339. And looking up the pinout for the 339, we can see that pin 4 is input 1, and that should be output on pin 2. And if we look at pin 2, we can indeed see a nice square output going from 0 to 5 volts, or close enough. So that appears to be working. Let's check one of the other receivers. So of course we've got 2 on both the vertical and horizontal axis. So this is the other one, and yeah, it looks tiny again because I've changed the scope back to 1 volt per division. But if we trace this one, looks like it ends up on pin 6. So that is input number 2, and that's output on pin 1. And look at that. It's just stuck at 5 volts, even though we can see there's clearly an input happening. Output is not moving. So even though both of these inputs look pretty much the same, only one of these is actually producing an output. So with only one of these outputs actually working, the Amiga won't be able to tell if we're moving the mouse up or down, so it's just not going to move at all. So at this point, you're probably thinking, well, it's got to be a faulty 339. That's what I thought, and that's why this thing is in a socket, because before this, it was soldered onto the board. But there's nothing wrong with this 339. I just didn't bother to check the other input, which is basically our reference voltage. So if we look back at the pinout, we can see that input 1 is on pin 4 and pin 5. So there's a negative and a positive input. And we only looked at pin 4, which has the tiny input from the receiver. On pin 5, we have what looks like a whole bunch of nothing, but let's zoom in on that. And what we actually see is something around 200 millivolts. I don't know where my scope is picking up all this noise from. Might be coming from the Amiga itself, but you can pretty much ignore that. Yeah, we're sitting right around 200 millivolts, and of course you can also see this using a multimeter. And we can think about that 200 millivolts as a reference voltage for the other pin. So anytime the other pin goes above 200 millivolts, we'll get a high on our output. And if it goes below 200 millivolts, then the output will go to low. If we go back to pin 4 and move the mouse wheel around, we can see that it does peak around 250 millivolts. And therefore we do get a nice square wave on pin 2 because our input is going above and below that reference voltage, so our output follows the same pattern. Let's have a look at pin 6 and 7, which are our second input, and pin 7 is going to be our reference voltage for this one. And once again we can see our reference voltage on pin 7 is around 200 millivolts, so let's have a look at pin 6 and give this wheel a little spin. And something you may notice is the peaks on this one pretty much top out, well, I'd say just under 200 millivolts. Therefore the output on this one, on pin 1, is just stuck at 5 volts because we're never going beyond that reference voltage, so there's no change on the output. And this could lead us back into thinking there is something wrong with one of these receivers, but I think the issue is more down to age than anything else. And although I've seen people replace the receivers and their mouses come back to life, there is a way that we can actually adjust for this and potentially adjust for any future changes to the voltage outputs from these things. And that's where all these resistors come in. And if you happen to have one of these mice, you might notice that some of these resistor values are different from the ones that you have in your mouse. These resistors are basically calibrated, or were calibrated at the factory, to match with these receivers. And over time, it seems like the specs of the receivers themselves have drifted out, and therefore we need to recalibrate these resistance values. And I highly doubt they were too careful in choosing, an exact resistor value. They probably just went with near enough is good enough, and if the mouse works, they shipped it out. So let's swap out one of these resistors for a trim pot and see what happens. So I've taken out R5, which is, I think it's a 680 ohm. Yeah, 0.685K, so yeah, 680 ohm. Let's throw in a 2K trim pot. So this one's designed to be mounted vertically, so I'm just going to bend out one of the corner legs, and we can install this where R5 was. So that's our trim pot installed. We can just leave that leg flapping in the breeze for now. I'm just going to set this to sort of its midway point, just so we don't have it set to 0 ohms. Let's see what sort of effect this trim pot has on our voltage levels. So I've just clipped the scope directly across this trim pot because this inner leg is going to be the output from our receiver here, and the outer leg is ground, and already we can see the voltage is a lot larger. Let's adjust the... Okay. So we're now seeing peaks around 500 millivolts, whereas before we were only seeing around 200 to 250. And of course, adjusting this trim pot, it's smaller that way and larger that way. So our trim pot, and previously the fixed value resistor, is working as a pull down resistor, basically bringing the signal from the output of our receiver down towards ground. And the lower that resistance value, the more it's going to get pulled down. But as we've seen, if it gets pulled down too low, then it won't actually cross that reference voltage set by the other input pin. Why they went for 200 millivolts, I don't know, but seeing that all the other inputs also have 200 millivolts on them, it seems to have been done on purpose. But clearly the output from some of our receivers has drifted over time and is now not strong enough to give us a proper output from the 339. So I've hooked up a second probe to monitor the other input, which we already know is around 200 millivolts, but it's just easier to visualize. And if we adjust this around, so at the moment, I think we're pretty much spot on. So as I move this wheel, we can see that it's crossing that threshold voltage pretty evenly on both sides. So we've got around a 50% duty cycle. That should give us the most accurate output, which also means the mouse cursor on the Amiga is going to be as accurate as possible for a ball mouse. Now, as I said, it is possible to do this with a multimeter, but it's going to be a lot harder to get this sort of at an accurate point, but you'll probably get it close enough that the mouse should work just fine. So at the moment we can see 0.3 volts, but if I slowly adjust this wheel, we can see somewhat similar to what we saw on the scope. So we're up to about 0.4 volts or 400 millivolts. If your multimeter has a min, max, and average function, then we can just set this to max and then just slowly turn this wheel, and yeah, it looks like 3.97 is the maximum reported value, and of course if I were to change this, that's going to go up, and now I've messed up the original setting. Okay, now it's saying we're at 4.17, which should be similar to what the scope will show us. So we can see our peaks are reaching around 400 millivolts, so double the 200 millivolts reference. So yeah, that's pretty much ideal. Now we just need to do the same for the other three. Disconnect all this, unplug our mouse, and while we're here we can get rid of this leg because we don't really need it. Just snap that off. So that was R5, and if we look at the back, it's pretty easy to trace out the other resistors. So one of them goes up to this corner one. So let's take this out, which is, looks like a 390 ohm. So yeah, definitely very different to the 680 ohm. So you can see they pretty much chose these values on purpose. Yeah. That's another one down. And that was R6, but we've still got two more to go. So let's trace out another one of these. This one goes up here to our 339 and also comes over to this resistor here. So third one down. And looks to be another 390 ohm, and that was in position R3. One more to go. Where is it? So this one comes up here, goes to a point there, and indeed that is a resistor, and we can see the other side of that is connected to our ground trace. And that's the last one out, and this one looks to be a 270 ohm. So yeah, definitely a mixture of values here. And that's R22. Well, so much for thinking it was going to go R3 to R6. It's R22, R3, R5, R6. Let's get a few more trim pots. So I'll try and arrange these so they don't get in the way of anything else, like the actual case. Ideally, we want to leave these installed so that should anyone need to adjust them again, it'll be as simple as popping the mouse cover off. Alright, all our trim pots are in. It's obviously not super pretty, but it's a lot easier than trying to design another little circuit board to stick them all on. And I think there's just enough clearance under there to put this board back over the top. So I've just set all these to their mid position, and this one here is the one we already adjusted, and it's pretty much right in the middle as well. So I guess 1K is the current ideal value, but maybe that'll change in the next 30 years. So it's probably good that we're using 2K trim pots because there's plenty more room for adjustment. Let's fine tune these other ones. So we'll start with this top corner one, and yeah, it looks like we're already at 400 millivolts. And it's going up to around 500, so we can bring that down a little bit. Just going to slowly turn this. Yeah, that's going down. Come back up a little bit. Yep, that looks pretty good there, so that one's all good to go. Let's do this one over here. So that's probably going to be this wheel. Yeah, there it is. And that's at 500 as well, so that can, oh, that's going up. Yeah, that looks pretty good. Maybe a touch that way. Yeah, that looks pretty good. One to go. All right, this one down here should be the other. Oh, wow, that's huge. That's a bit too much. There we go. Yeah, that looks pretty good. And switching back over to the Amiga, here we go. It works. Perfect. And if this ever stops working again, it should be as easy as opening up the case and twiddling these pots, assuming the person who does it has seen this video. And with our mouse reassembled, oh yeah, that's perfect. Ah, I was gonna change those dome switches, wasn't I? Damn it. They just feel a little bit mushy, which tends to happen to dome switches over time. Probably should unplug the mouse for this. So these are just held down by a little bit of tape. So if we lift that up, we can also give these contacts a bit of a clean, just with a bit of IPA. And just peel off our little dome switch. That's all they are. And somewhere around here, yeah, I have brand new ones. These are a little bit different. Oops, that's gone forever. These, as you can see, are a little bit different. They basically have 4 contact points, but as long as we arrange it so the legs are not touching that trace coming up through the middle, we should be fine. We can just stick that back down. That tape still has a decent amount of stick to it as well, so I think that'll be fine. You could also use just some Kapton tape and use that to tape them down, but yeah, that feels fine. Let's do the other one. That looks pretty good, as long as it doesn't move. Yeah, I don't think they're going anywhere, and they feel nice and clicky. Let's make sure they actually still work. Oh yeah, perfect. There we go. That's better. Dare I say, this is probably better than it was when it left the factory. So, like I said, I do have one other mouse that is doing the same thing, and yeah, the internals of this one are likely going to be the same. But before I look at that, let's check out this slightly different model. And this one is made by Mitsumi. I think the other one was made by someone else. So, yeah, Mitsumi stuff is generally pretty reliable, and this mouse, as far as I know, is working just fine. Oh yeah, no issues there. And our mouse buttons are working just fine. Let's just have a look at the voltages on this one, see if they're close to being out of spec as well. So let's have a look at one of the inputs on the 339. And that's the output from the receiver, so the other pin should have our reference. And it's a little bit higher than the other mouse, around 360 millivolts. So we want this to be hovering around 700. Looks like it's actually going up to around 900. I guess that's fine, as long as it's not below the 350 or 360. I guess that's okay. Let's have a look at the other one. So yeah, same deal, reference is around 360, and that's also going up to a little bit over 800, so that's fine. And on the other side of this should be our horizontal. That's our reference, 360 again, and yeah, about 800 millivolts. And for this one, 360 and 800 millivolts. Yeah. So yeah, that's perfectly fine. It doesn't seem to have drifted at all. So maybe Mitsumi used higher quality IR receivers. I don't know, but no issues there. But if there were, I guess we could also install trim pots in this mouse. In fact, let's pull it out and have a look on the underside. Okay, and the arrangement is a little bit different on these mice, but it looks like we've got some resistors up here. In fact, there's even the label of 1 and 2, and resistors over here, which I'm guessing underneath that old flux says 3 and 4. Indeed it does. Ugh. How fluxy is that? Ew. Look at all that nastiness. So yeah, on the Mitsumi mice, they've even labeled them 1, 2, 3, and 4. And it looks like they've actually used pairs of resistors, which are connected in parallel. So we've got a 680 ohm in parallel with a 2.2K. So what would that give us? 500 ohms or something? I guess they spent a little bit more time fine-tuning the resistor values on the Mitsumi mice. But yeah, this one seems perfectly fine, so I'm not going to mess with it. Oh, and in the other mouse, they've only used single resistors, so they haven't paralleled these ones. They all look to be the same value. I think it's, are they 520 ohms or something? So there you go. But I'm pretty sure this mouse, like the other Mitsumi one, should work just fine. Yeah, no issues there. And I just found out that the overhead camera shut off without me realizing, and I think I've been talking to myself for the last half an hour. But you didn't really miss much. I opened up this mouse. It had the same problem, so I swapped the resistors out for trim pots and, adjusted them accordingly. And yeah, it used different resistor values compared to the first one that we looked at. So these are definitely, hand-picked at the factory, or at least based on some kind of data that they had. So I don't know if they individually measured all the receivers somehow and worked out the correct resistance values, or if that data was provided to them by the receiver manufacturers. No idea, but at least the resistance values in this are now perfectly accurate. I mean, that could change over time, but we won't know for another 30 years probably, so I don't think it's really worth worrying about right now. And on that note, I think that is it for this one. So thank you all for watching. A huge thanks to the people at Sport Channel on Patreon. If you want to do the same, links to that are in the video description. You'll get ad-free early access to all videos, along with some other perks, discounts on the Tindy store, and of course, help keep this channel going. And yeah, that's it from me. So thanks for watching. Bye. Mouse, 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 mouse.